Hello guys, it's Shravya today. Please subscribe to my channel. Anyway, today I'm going to be explaining you about the properties of a parallelogram. To help me explain this property, I'm using the parallelogram ABCD. And I drew a copy of it for each problem since they all are on different pages, including the first one, even though they both are on the same page. So I marked this drawing with all sorts of congruency and parallel markings, but anyway, I'll explain those soon. So the first property is opposite sides are congruent. Here's why that is true. The first step or thing you have to know to understanding how opposite sides of a parallelogram is to know that the opposite sides of a parallelogram are parallel. Well, that does help understand, but that's not really the main thing. The second step to understand this property is to split the parallelogram into two triangles. This is the more critical one because this is where you can actually start finding out. The first step is actually like a side step. So here basically I divided parallelogram ABCD into two triangles, which are ABC and ADC, using the line segment AC, which is the diagonal. The third step is to understand that the two triangles in the parallelogram are congruent. Well, you can use the reflexive property and some parallel line properties, but this parallel line thing will help reassure you why these triangles are congruent. But anyway, the fourth step to understand is by the CP/CTC, which is basically like that all congruent parts of congruent triangles are congruent. It's basically what it is. Congruent parts mean sides and angles. The two shorter sides of the two triangles are the sides of the parallelogram. And those are basically sides AD and AC for triangle ADC, and sides AB and BC for sides ABC. Those are the two shorter sides again. And they are all opposite to each other and congruent. So based on this, the opposite sides are congruent. And moving on to number 2, which was the most straightforward thing to me because parallel lines are straightforward. If you just know that alternate interior angles are congruent and alternate exterior angles are congruent, or stuff like or corresponding angles are congruent, you should be fine with this. And also problem number 4, which is something similar. So anyway, the second property is opposite angles are congruent. Basically this means opposite angles of a parallelogram are congruent. In this paragraph over here, in pink and 2 different shades of purple, explains why, and I'm going to go over that paragraph with you right now. The first step to understand how opposite angles are congruent is to know that the opposite sides of an angle are the first step to understand how opposite angles are congruent is to know that the opposite sides of a parallelogram, that's just a typo, are parallel. The second step to understand this property is to know that alternate interior angles of a set of parallel lines cut by a transversal are congruent. Opposite angles of a parallelogram are the alternate interior angles. And that is basically like, for example, that the parallel lines DC and AB, which I extended, they have the transversals AD and BC? Well, yep. So these are basically considered alternate interior angles of parallel lines. Well, basically it makes more sense with these purple parallel lines. Well, you can also do corresponding, but I just decided to do alternate interiors. And then the same goes for the other set, whatever was said in the second step. Based on this, opposite sides of a parallelogram are congruent. And anyway, number 3, which was the hardest. It's basically like diagonals bisect each other. The first thing to know for this step, which is written in a bloody red, is that you can create diagonals that can split the parallelogram in half. All you need to split the parallelogram in half is only one diagonal, which basically means that to split it in half, and basically here, to split it in half, you only needed, this way you only needed one, and split it in half this way over here, you only needed one. Second thing to know is that you can draw the diagonal from left to right or right to left. That's basically like it can create an X. The third thing to know is that the diagonals are congruent, and I know that because they can only intersect the parallelogram's vertices, and that too, repeat, that too, only the opposite ones. So basically A cannot intersect D or B, it can only intersect C, and the same goes for other things. The fourth thing to know is that if the conditions are like the ones said in the third thing, there will have to be a common midpoint for both the diagonals. And if there is a midpoint that they share, the diagonals bisect one another. Anyway, number 4. The property, or the fourth property, is consecutive angles are supplementary. The first thing to know again for this, and this time it's more critical and crucial, is that sides of a parallelogram are parallel. Second thing is to know that in parallel lines cut by a transversal, same side interior angles are supplementary, which is basically angle BAD and angle ADC. And that applies to the rest as said here. And based on this, we know that basically, same goes for the other consecutive angles, like angle BAD and angle ADC are consecutive angles of a parallelogram, which means they're on the same line segment. And based on this, we know that consecutive angles are supplementary.